So the goal today is to graph a bunch of lines on our graphing calculator, like systems of equations, but also graphing them on paper, doing both, okay? And on top of that, we're gonna find where they all meet. Like the different lines will meet at different points. And so I'm gonna show you on the calculator how to do it. It's not gonna be brand new. We've done stuff like this in the quadratics unit, so I'm actually skipping a bunch of things, okay? So if you go to page 9, it says graphing lines with TI-84. Sometimes I use this, I start with chapter 6, but I already did quadratics, all right? So I don't need to teach this part on how to graph equations on our graphing calculator. So I'm actually skipping this. I'm also skipping using your window, right? I'm not going to show you how to use your window again. Obviously, when we do examples, I will. But you should just understand that sometimes if your window settings aren't right, the line is graphed by the calculator, but you're just not seeing it until you change it up, right? And all of a sudden, like, remember, this is your Y max at the top. This is your Y min. Then you have your X min, X max. So if that's basically like, those are the boundaries of your window. That's what you're seeing, okay? You remember that stuff? I hope so. So let's go to page 10. I think I will also just briefly skip over understanding zoom, right? So if you've got zoom standard, right? Standard just gets you to a basic window where everything is 10 everywhere you go from the origin, 10 in every direction. Zoom fit often helps you out, but it doesn't completely solve your problem. You might still have to make some changes after it, but zoom fit is definitely something you may use. And then sometimes zoom stat, right? We've used that as well with quadratics when we did regressions. So I would say this zoom stat, it's only if you're doing some kind of regression and plot one needs to be turned on, okay? We're not doing regressions and linear in this unit. That's only a quadratics thing, okay? So I hope that kind of rings a bell. If not, that's okay. We're gonna encounter that as we go along. So here is where we're gonna start with only 2 lines, and then we're gonna add more to it. So you're gonna have probably 3 to 4 at the same time. Once we get to like the highest level, the most difficult part. All right, so here we go. Graphing using technology. So for each of the following, I want you to rewrite. I want you to graph on a calculator. And then I also want you to determine the y value when x is equal to 7. Okay. I also want you to find the intercepts using technology. You know what? I may not use technology. I may just do it by hand. I think I'll just do it by hand. It's faster down the road. And also determine the x value and y is equal to 15. So let's do the first 3 here as first and foremost. What do I mean by rewriting? So I, right? By that I mean write into y equals mx plus b. Y equals mx plus b. I'm going to zoom into that side for now because we're staying on that side. That way you can see a bit. And why would I want to do this, folks? Any idea? Maybe it's too early. But I would want to do this because I want to enter it into my calculator. If I want to graph it, it has to be in this format. A calculator cannot handle anything that isn't where y isn't isolated. Maybe 10 years from now, they'll make a TI where you can just punch it in the way it is and it'll just graph it. But until then, we have to do it this way. So let's do the rewriting part. 2y stays. The 6x comes over adding, right? 6x is positive when it comes over to the right side, plus 30. Then we divide both sides by 2. Y is equal to this would be 3x, and this would be 15. You're done. There's no fraction or anything. I'm just going to warn you, if my y-intercept, listen carefully, if the y-intercept isn't a nice number, if it's like an ugly decimal when you divide it, I leave it as a fraction. I enter it as a fraction into my calculator. Because then you're including all of the values, right? If you enter it as a fraction. So you'll see it'll show up. So let's graph this. I'm just going to put check mark there. But let's see if you remember how to do this. Grab your calculators. You should all grab your calculators. If you do stuff, you wake up, you know what I mean? So y equals, I have some ugly equation on there. We're not using regressions, right? We're not using that. So plot 1, 2, 3 should be deselected, not turned on. So let's just enter this equation, 3x plus 15. And let's hit graph. My window, I can tell you it's going to be very off, but I'm going to try it anyways. Oh, I see the line, but I want to see the intercepts. So I'm just going to try zoom standard, this one, the 6th one. Let's all do it maybe, so we're all seeing the same thing. This is a standard window. In this case, I have my x-intercept. I still want to see the y-intercept. So I need to go to window, and what am I going to change? Y max, right? What should I change it to? You can tell, look at your equation. What's your y-intercept? 15. So I'm going to go 20 for my y max. And that's all I need to see so far. So we graphed it. Pretty good. All right, so put this aside again. Don't erase anything. We'll use it. We'll just add to it. Triple I. The intercepts. Let's find the x-intercept and the y-intercept side by side. Oh, yeah, okay. So let's x-intercept. Okay, careful here, guys. You can use either one. Okay, look up here for 1 second. You can use this one. You can use that one. There's the same equation. Talking about the same line. This is like dressed up. This is a Halloween costume. It's still the same person. And this is the original, right? So I tend to like this one more. So I'm going to use that one. So when it's x-intercept, y is equal to 0, right? So 6x equal to 30. The 2y disappears. Okay. So x is equal to, very important to get your sign right, -5, right? -5. So I found a point, -5, 0. It shouldn't take up too much space, right? Like just nice and compact. Next, 2y is equal to 30. Because x is equal to 0, right? The 6x, the -6x technically turns to 0. So you're just left with 2y is equal to 30. Divide both by 2. Y is equal to 15. So 0, 15 is what you found. Box this in, nice and compact, as I said, because you're going to need that for graphing by hand. I by far prefer this method because then you know exactly where they're going to go through, and you just plot them down on the x and y axis, and boom, you connect them, you have your line. Okay. All right. Let's stop there and go over to the other side and do the first 3 steps with the other side. Maybe I'll give you some time to try this. Oh, was somebody still writing this down? I'm just going to leave it there for now. Can you try rewriting it, then graphing it on your calculator, and then finding the intercepts? Can you try that? Give it a try. This is kind of like your mental math for today. All right. Compare and contrast. Contrast and compare. Let's see. I personally, this is workable, but remember my preference is have all the variables on one side and have the actual number on one side. So I'm gonna, well, I told you to rewrite into this form, so what I will do is this. I'll just do that first and foremost. So negative 5y stays. This one and this one, these two terms, they go over to the other side, right? So equals 4x plus the x here. The 100 comes over adding. Okay, so that's my first step. I'm going to clean that up a little bit. That's 5x plus 100. Divide both by negative 5. And 5 and negative 5, that's just negative 1, right? So it's negative x. And this is negative 20. So this is the equation that you should have. This is the one you can enter into your calculator. So that's going to be very important to us. So let's go ahead and do that. Maybe you already did. So make sure you enter negative, not minus. If you go minus, you're going to get an error. So negative x minus 20. Let's go ahead and graph it. Can I predict something about this line? Let's do this on the side here. Slope is negative, so my line from left to right is going to drop. Right? So you should be able to be like, oh yeah, that's right. And my y-intercept is going to be, you're looking, right? That's negative 20. Once it's isolated, that you have information here. So let's graph it. Uh-oh. Can't see it. It's probably because of this, because of the negative 20. So let's go to window, and we're going to go to y min. I'm going to go even further down than negative 20. I'm going to go negative 30, and then hit graph. And there I start seeing it, right? So what else do you need to do? You need to decrease the x min. Okay, so I'm going to go window, x min. I don't know, what do you think? Negative 20? I'm going to try it. It's not quite enough. I'm going to go negative 30 as well. I just like to see well beyond. Perfect. So there's my line. There's this line, which I do expect to drop from left to right. It goes through negative 20. Because remember, right now, this is your negative 30 at the very bottom here. And it's negative 30 way over here at the x negatives. Okay, I think you got it. Let's move on. It's probably the biggest complaint student has, like, you just gotta move on. I know. Sometimes I get stuck. Okay, third one. Let's find the intercepts. X-intercept, y-intercept. Okay, so x-intercept. Which one should I use, Mr. Dixon? Which one? I like to, maybe I will do that way up here. I'm just going to go negative 5y minus 5x is equal to 100. What have I just done here? I took this original and I brought the x over to this side, combining it with that 4x. So end up with negative 5x. And I brought the 100 over to this other side. I like to have it in this format when I do the intercepts. Okay, so x-intercept, my y is equal to 0, so I'm going to end up with negative 5x is equal to 100. Divide everything by negative 5. And if you get the same answer, that's fine, like you're good. Like, there's nothing you need to worry about. Okay, negative 20, 0, and then the other one is going to be the same, correct? It's going to be negative 5y is equal to 100. Divide everything by negative 5. Y is equal to negative 20. So it's 0, negative 20. Should I make a note here? rewrote. Is that football? Football or what? Wow, pretty dedicated this weather. Did you? You're not gonna find out yet. What? You're gonna find out later if you made it, or what? Yeah. Okay. All right. We're on page 10. Okay. So now what? So I'm just telling you, like, I rewrote to have it like that. Okay. Okay. What else do we need to do? The 4 and the 5. What does it say? 4 on. I'm going back to the left side. I'm going back to the left side. What does it say? Determine the y value when x is equal to 7. So it's basically saying when x is equal to 7, what's y? How would we do that? Do you remember using the calculator? Don't look at me, Mr. Dixon. I'm not going to answer. No way. Do you remember? Which entries did you use on your calculator? Maybe I'll do this. Second, trace. Which one of those would you use if you know your x value? 1 value? Yeah. Second, trace 1, right, for value. X is equal to 7. So let's go and figure this out. Second, trace 1. I'm going to enter 7. Watch this. This is pretty cool. We have 2 lines, right? Well, which one is it going to pick? So watch what's going to happen. So just hit enter. Which one did it jump to? It jumped to the 3x plus 15, right? That's this one we're on right now. You see it? And so what's y there? Look on their calculator. It says 36. So we're going to go y is equal to 36. Don't touch anything. Just leave it like this. There's something cool I'm about to show you. Now we're going to go to the other side. You might not find it as cool as I, but x is equal to 7, y is equal to, and we're going to go second. Don't type this in, please. This is what you would do if you hadn't already done the work before. Just write that down first, yeah. We're going to go arrow up or down, and the calculator is immediately going to jump to the other line. Watch. If you go arrow down, it goes to the red line, which is the other one, and it gives you the answer for it, which is negative 27. If you go arrow up again, it gives you the y value for being on the blue line. And by the way, 736, like just follow my pencil, is probably way up here somewhere. Right? That's why you're not seeing it. But as soon as I go down arrow, it shows me like when x is equal to 7, y is equal to negative 27. Okay, so that's a pretty cool feature. It saves you a ton of time if you're doing this already. So what did you just find? I found a point. And that is what? 736 for this one. You're just saying, hey, this point is on the line. And same here. You found a point 7, negative 27, which is on the other line. Okay? So keep that in mind. What about the other one? 5. You're down here, V. If you are given the y value, when y is equal to 15, it's saying what's x? What would you do in that case? Anybody? If you know your y value, it's been a while, right? Remember, y2 is equal to 15. And then we're going to go second, trace, intersect. So once you have written this down, let's grab our calculators and do it. We're going to go y equals, not y2, correct? y3. So go to y3 and make that 15. Is it going to be on our graph? We will see. We shall see. Hit graph. Oh, it made it. So we still want to see a little bit more here where it meets out here. So look up on your screen and change your window. Maybe you do it yourself. Change the window so that you can see that intersection. Okay. Change your window. What would you do right now to be able to see this intersection out here? What would you do? What would you change? X-min, right? Yeah. So we're going to go X-min. I'm going to go -50 because I'm sick and tired of just typing in numbers. There we go. That's a pretty good one. So you go second. This is a little different, okay? So you got to go second, trace, intersect. And right now you're on the blue line, watch. If you go arrow up or down, oh, I'm going to the right. I'm traveling upwards right now. And so you need to go, you're trying this, right? You need to go as close as possible to this intersection. Let's say I want this one first. I'm going to hit enter one time. And now you need to jump lines because right now you're on the red line. Okay, so you're going to jump. How do you jump lines? Up and down arrow. So you're going to go up arrow. You're back on the blue. You don't want that. You want to go up arrow again until you get to that other one and just get as close as possible. That's close enough, to be honest. So once you've selected like the two lines you're curious and finding the intersection for, then you hit enter one more time and just guess. And so the intersection is 0, 15 for the blue line, which is this one here. X is equal to 0. Just write that down. It happens to be my y-intercept. And then let's do it one more time so we find the intersection up here. Y is equal 15, and then what is it for this red line for the second option here? So let's just write this down. Y2 is equal to 15. Second, trace, intersect. So in this case, you cannot just find it as easily as the other one. So we got to go second, trace, intersect. And now I don't want to be on the blue line. So I'm going to jump. I'm going to jump to either this one or that one. It doesn't matter. Jump. Okay, there. So now I'm going to travel as close as possible to this one because I'm interested in that one. Hit enter. Then I'm going to jump to the red line and it just happens to jump right there. So this is close enough. Just keep hitting enter until it calculates the intersection. And that's, in this case, x is equal to -35. Whoa, what just happened there, right? Like, what did you do, Mr. Dixon? You're going to have to practice this, okay? It's all about practice. After, next thing you know, you're going to just click away and just do it quickly, right? You're not going to spend as long as I do right now. But you have to practice. Do it for yourselves, right? Don't just do it for me. Anyway, so we found like when we're given an x value, what's my y value? We've done that. But we've also, been able to figure out, hey, if the y value is something, what is the x value on that line? So we went both ways. And we did this in quadratics already, but I do realize it's been a while. Okay, time to graph on paper. So come with me to page 11. And this is important. Determine the point of intersection of two or more lines, and we're calling this POIs, or corner points. Points of intersections are going to be very important to us in this unit. Can you write down corner points, like right next to it? Because some questions refer to it as the corner points. Points of intersections or corner points. And this is basically just summarizing what I just did with you, right? Enter your lines into Y1, Y2, Y3, as many lines as you have at play. Then press second trace intersect, select the first line using up and down arrows, then press enter. Select the second line using up and down arrows, then press enter again, and enter one more time when it says guess to actually start figuring out the points of intersection. So let's find the point of intersections of the two lines that we had above, like the two equations that we've been dealing with. So grab your calculator. I'm going to turn off the Y3 because that's something we just entered after all. So just hit clear and then press graph one more time. We just want the two diagonal lines that we worked with right from the beginning. And in this case, the point of intersection is basically where they meet. Okay, so how would you do this? You would go y1 is equal to 3x plus 15. Y2 is negative x minus 20. Can you see that? Sorry, guys. Okay. And then just go second trace intersect. Okay, so let's find that point together. Second trace intersect is 5. And because you only have two lines, you could actually just close your eyes and just press enter 3 times and it's going to find it. But sometimes you're going to be off the window, so just I travel up using my side arrows, and then it's going to be enter, and you're already on the other line you're interested in finding the intersection for, and just keep hitting enter, and that's negative 8.75, negative 11.25. Okay, so negative 8.75, negative 11.25. I can't tell you how important it's going to be to find those POIs, right? This is the POI. In this case, there's just one. Okay? And now we're going to graph this thing on paper. So you ready? You're going to do a lot of graphing, so you got to be pretty good at it. If you have a ruler, that's probably something to make a straight line. I don't want no squiggly lines, okay? So to graph these lines, I'm going to do this for you, for us, just to, usually it's going to be on the same page, but I'm just going to do this on the top here. Y is equal to 3x plus 15. I'm going to say that we have negative 5, 0 as our x-intercept, and we have 0, 15 as our y-intercept. And for the other equation, we had negative 20, 0, as well as 0, negative 20. Okay, so those are important to have there. So let's pick a scale. What do you think should be account for? You're going all the way up to 15 here. You're going all the way to negative 20 here and negative 20 here. So let's just make everything 20, like go up to 20. Would that work? Let's try it. I'm going to go 5, 10, 15, 20. Whoa, he's going up by 5s, right? Yep. 5, 10, so negative 10 that is, 15, 20, negative 20. And I'm going to do the same. I'm using the same scale in this case everywhere I go. Negative 5, negative 10, negative 15, negative 20. Sure, you could have gone up by 10. Absolutely, I don't care. You do whatever works for you. X and Y are already labeled. Make sure you label them, okay? And let's plot. So let's do the first line. Negative 5, 0 is right there. And 0, 15 is right there. And maybe I'll use a red pen for this one. And maybe I'll use a blue one for the other one. But here's our first line. And I don't want to lose marks, so I'm going to go 3x plus 15. Just put it on one end. Don't put it in the middle because it's going to get busy. So just put the equation at the very end so that it's not interfering with what we're doing. The next one. Do you know how to plot points, guys? I hope so. I hope so. I know you know, but sometimes a negative 20, 0 shows up here. Negative 20, 0, right? So you got to watch out. Negative 20, 0 and 0, negative 20. By the way, guys, you have your calculator. If it doesn't look like it's on your calculator, if the lines are like parallel or doing something weird when you do it on paper and your calculator is showing something different, you're like, wait a minute, something is off, right? I hope. So I'm going to grab a blue pen for this one. And there you go. Look at that. And I don't want to lose marks, so I'm going to put the equation at the bottom here, somewhere at the end. So I'm going to go y is equal to, Mr. Jason, which one should I use? Should I use the original or the one I rewrote? The answer is, I don't care. As long as it has a name attached to it. And this one is very important to us. What do we call this one again? The POI, the point of intersection. And I'm actually going to label that one. This is negative 8.75, negative 11.25. And it does sort of work out, right? It's almost negative 9 in terms of your x. And it's a negative 11. It's not quite 100% when you look at this side, but we're not going to sweat it. I'm quite often going to give you a grid, not just a line, quite often, so it should be pretty bang on when you do it right. This is it. Okay, so we labeled. You don't have to, the points here do not need to be labeled because you will have shown me somewhere where that you calculated them, so I'm good with that, okay? But I don't like squiggly lines. I don't like you hand bombing it, and then you're gonna lose marks. It has to be nice straight lines, okay? All right, I'm gonna stop talking for a bit. Just get rid of, don't worry about the homework down here. I used to have a workbook and a notes book, and I just merged everything together. It's just better to have it all in one place, so don't worry about that. So this is where you come in. It's going to take you a little bit of work. I'm not going to lie to you. We're going to go over to this table. It's called the calculator worksheet. And I need you to become really good at having a whole bunch of lines showing up on your calculator. Okay? And maybe because you know what, I'm interested right now in you using your calculator properly. That's what I'm interested in today. So I'm going to rewrite this for you real quick. So go to page 12. So you just have to copy, right? As long as you copy, you're in business, okay? So this is kind of how I want the equation, but I need to rearrange it into y equals mx plus b because all of these are going to end up on our calculator, all of them. So I'm going to show you how I do this. Negative 5y is equal to negative 3x plus 30. Divide everything by negative 5. And then y is equal to 3 over 5x minus 6. Because the 30 gets divided by negative 5, right? Can you see that? Let me zoom in a little bit. There. Is that better? Okay, so this is the one you're going to enter for y1. And next one here, 3y is equal to, the 17x comes over subtracting. There's already a 45 there. Divide everything by 3. Y is equal to what? Negative 17 over 3? Yes, just leave it like that. Your calculator can handle it just fine. 45 divided by 3? 15. All right, one more. Decimals. I don't like that. I think it's going to work out all right. But remember, guys, if you have decimals and you don't like them, what would you do to this whole equation to get rid of the decimals? Times it by 10 in this case, if you don't like the decimals. But I think this is going to work out. So I'm just going to go 1.5y is equal to 4.5x plus 18. I don't need you to reduce fractions. Okay, so you're probably like, yes, right? We don't, because that's not the goal in this course. It's solving problems. 4.5 over 1.5, that is actually exactly 3. Okay. 18 divided by 1.5 is exactly 12. So, phew, right? And what's up with this? They give you $100 if you, no, I'm just kidding. 2 divided by 3 plus 1/3 x. The thirds, I don't like them. I'm gonna multiply by 3. I'll multiply this whole thing by 3. So I'm gonna go like this, times 3. And that essentially, all the thirds get taken off. So it's 2y plus just x, because the third cancels out with this 3. And then it's 4 times 3, which is 12. So 2y is equal to negative x plus 12. Divide everything by 2. That's, what's this going to be? Negative x over 2 is negative 1/2 x. 12 divided by 2 is 6. You're going to be pros by the end of this. Go ahead. Okay, so now it's moment of truth. Grab your calculators. You're like, what about the x-intercepts and the y-intercepts? Just wait. Like, we'll deal with that in due time. I know you know how to do it. Grab your calculators. Hit y equals. I'll show you a bunch of tricks, guys, that I've picked up over the years, okay? Some students prefer one way, some students prefer it the other way. I need you to look carefully. I think I've done this in quadratics already, but are you looking up? Okay. 3/5. Don't just enter it like that. What do I use? I use brackets. Okay, so I will go 3 divided by 5, close it like that. Enter that in brackets like that, and then just x. Remember your x button? Right? Minus 6. That's how I enter the first one. Keep going. y2. Negative 17 over 3. X plus 15. It looks weird on the calculator, I know, but it's all right. Next is 3x plus 12. And last but not least, negative, right? So negative 1 divided by 2. So that's 1/2 x plus 6. I hope you're all entering this. Now, want you to find the intersections between these lines, but I don't think it's a good idea to have them all going at the same time. I don't think so. I can do it because I've done this many, many times, but I'm not sure if you will benefit from it. So you've entered them all. Let's just graph it let's just see what this looks like if we graph it, shall we? Let's graph it. 1, 2, 3, 4. That's not bad. Do I need all of this x in the negatives here? Do I need all of that space? I don't think so. So I'm going to go with, should we do zoom standard? Zoom standard. Yes. I'm going to go zoom standard. Why? Just so we all see the same thing. And I'm pretty sure it's going to work out for us. 1, 2, 3, 4. That's there's a bit of a problem, correct? My y max is a little cut off here. I need to see a bit more. And my x max, easy fix. I hope I'm not too fast, but I'm going to go window. X max, I'm going to go 20. And y max, I'm going to go 20 as well. If you have a different teacher in the future, they might play around with the scale. I never play around with the scale because it really doesn't matter. It doesn't change anything. Hit graph again. 1, 2, 3, 4. Perfect. Oh, you might be saying, hey, it's a bit cut off here, right? I'm pretending to be you. Am I doing a good job? It's a bit cut off here, down here. So my y min should probably change as well. I want you to be critical. I don't want you to just follow what I'm doing. I went to negative 15, by the way, on my y min. So this is pretty good. All of them are crossing. This will take care of all of it. Now, this is the trick of the day. You want the trick free? Is this free? If you just want y1 and y2, so go on your paper here, determine the intersections of lines 1 and y2. I go on my calculator, I press y equals, I go to the equal signs, hover over to the equal signs of y3 and y4, and I will hit enter. You deselect them, and then you hit graph, and you only see the two lines you're interested in finding the intersection for right now. And the next one is y1 and y3, correct? Then you go, well, y equals, turn off y2 and just have y1 and y3 going at the same time, but you have to hit graph every single time. And then you find that intersection and so forth. So you're just going to play around with it and find them all, okay? As well, hold on. So that's part of your job today, as well as finding the x and the y intercepts for each equation. You know what? I'm okay if you don't do this part. This part is, I'm okay if it's just optional for you right now. Okay, so I'll say these two columns are optional. I just want you to find the x-intercepts and the y-intercepts. Okay, find those and find all of the points of intersections here. And once you're ready, come with me. It's gonna be, it gets pretty cool. We're gonna transfer all of these intercepts, like you're gonna do one at a time, of course. You're gonna grab these two intercepts, go to the back side, ta-da, right? You're gonna put those x and y intercept on here, graph that line, and then you're gonna go y2, x and y intercept, like wherever they're supposed to go, connect those two, graph that line, call it, you can call it y1, y2, I'm fine with that for today. And you should see everything on here just like on your calculator, okay? That's your goal for today. All right, so get going. If you have questions, ask me. But the rest of the class is for you to just get these 2 pages done, and I'll post the key in a bit, okay?